All right, so today we're going to be talking about right angle trigonometry. So we've already talked about one topic out of this, which is basically the what's it called? The Pythagoras theorem, right? And we've already also talked about a little bit about circle theorems. You know how you can make little angles inside a circle and these will be equal, blah blah blah. Those were from the last class.
Yeah.
But today we're going to be talking about right angle trigonometry. So what do I mean? This is the study of triangles with right angles in them. So like a triangle that is right angled 90 degrees. We're talking about rules specific to these guys. We already know one rule, which is the Pythagoras theorem, right?
Where that thing or I know you're talking about one. Okay.
So you know this, right?
Yeah.
Uh, Why are you
No,
saying yeah? Like it means you're familiar, right? We talked about this. We worked some examples on this too.
no, yeah. I'm trying to find something.
Okay, so this is clear, right? We can move on.
Mhm.
Okay. So today we're going to be talking about the Pythagoras theorem is only about the relationship between sides of triangles, right? Specifically sides of right angle triangles. So now we need to talk about relationships between angles and sides. Okay?
All right.
So basically imagine that you have a right angle triangle and let's say that this is an angle that you know of. For example, this is 30 degrees, okay?
Mm-hmm.
Now, in this right angle triangle, once we know this angle, what we do is we first name these sides. We name this side. Do you know what we name it?
Opposite.
Opposite, exactly, because it's opposite to the angle. We call this one the adjacent and we call this one the hypotenuse. The hypotenuse is easy to remember because it's the hypotenuse, right? The one that's not perpendicular. So once you've named these sides, some interesting situations form. The first one is that there is a operation, I guess. You know how there's plus, minus, square, cube, square root, all of these operations?
Mm-hmm.
There's three new operations that you're going to learn about that might be a little bit more unintuitive than add, subtraction. Okay. So remember how the first time you learned about plus, you were probably very confused. I mean, it's been years now, but or when you're a kid, it doesn't really make much sense. So try to look at this the same way. This is just an operator. This does something to a number. Okay.
Okay.
Specifically, it does things to angles. You can only put an angle inside a sign. Okay. Remember, this is, by the way, a word of advice. Sign, if I write sign alone, it means nothing. Just like if I write plus alone, it means nothing. I need to put a number next to it. Otherwise, the plus alone means nothing. So similarly, sign alone means nothing. Sign needs a number inside it. So for example, you can put 30 here because you have a 30-degree angle here. Now, sine of 30 is a thing. Okay, it'll give you a number answer. It'll be a decimal answer. Okay. In your calculator, if you write sine 30, you'll get an answer. The cool thing is that this will always be exactly equal to the ratio between the opposite side of the right angle triangle divided by the hypotenuse side of the right angle triangle. Okay?
Okay.
So the sine of this angle will always be opposite over hypotenuse. Similarly, cosine is another identity, or cosine is another operator. Cosine of an angle is always equal to the adjacent over hypotenuse of the triangle. So the ratio between the length of the opposite side over the hypotenuse side will always exactly equal the sine of this angle. Okay? And
Mm-hmm.
finally, tangent of your angle will always be exactly equal to opposite over adjacent. Okay?
All
So
right.
now, do you know a method to remember these? Like, do you have what's it called, mnemonic?
It's a SOHCAHTOA kind of thing.
Exactly. SOHCAHTOA. Sounds like a magic spell from Harry Potter, but that's a interesting way to remember it. So now, let's look at some problem solving. Okay, because I mean that's really the most important part. How do you solve problems with this idea? So imagine, so the way I kind of remember it. Sorry, give me 1 second. Okay, so the way I remember how to use these three rules is number one, very important. These only apply to right angle triangles. Okay, never ever try using this anywhere that is not a right angle triangle, and always use this whenever you have a right angle triangle. So these are special for right angle triangles. Now, number two, whenever you know any two things about a triangle, meaning you know an angle and a side, or you know two sides, Any two things in a right angle triangle, you can use one of these rules to find out the missing stuff. Okay? So
Okay.
whenever I give you a right angle triangle where I give you two pieces of information about it, imagine like immediately go for one of these three. Your goal would be to figure out which one to use. So let's do an example. So imagine that you have a right angle triangle and I give you this angle, 25 degrees, and I give you this side. See, I given you two things, angle and side. Okay. So which rule will I use is the question now. I know for a fact I have to use one of these three, but which one is the question? So label the sides. What is this side going to be called?
Opposite.
This one,
Which one?
this down here,
It's
adjacent, right?
adjacent.
And this
Yeah.
is hypotenuse. So now let's say that you want to find the hypotenuse. Find hypotenuse and adjacent both. So let's start with hypotenuse. How would I find the hypotenuse?
So to find the hypotenuse, it would be sin sin 25 sine 25
Hmm.
is equal to 4 over, let's say, x.
Yeah, we can call it
Uh,
H for, So now, can you
oh
try
yeah,
to solve this on your, by the way, you need a calculator for this class. Do you have one?
yeah, I have one here.
Okay.
So
Can you find out what this ends up being? Like solve this for H?
um to like decimal places or
Like two, sure.
sorry,
Yeah, two decimal places.
1.69. Yeah.
How did you get that?
Oh wait, no, I pressed the wrong one. Wait, sorry, it's 0 1 0.
How
No,
how
one
did you
two.
do that?
Sin 25 divided by 4.
No, but that would be 1 over H. See, if you divide both sides by H, you would get 1 over H equals sine 25 over 4. So what you just found is 1 over H, but you need H. So how would you find H now? You see what I mean, right?
You times by 4.
If you times both sides by 4, this would become 16 and you would have a 4 here. That would still be pointless.
Mm,
What I
okay.
do instead is I told you about this by the way. So whenever you have two fractions equal to each other, you can just move things diagonally. So I multiply both sides by H to first get rid of the H from the bottom because the thing I'm trying to find needs to be at the top. That's the first thing. Now it's at the top. Now I divide both sides by sine 25. So you see the H goes up there and the sine 25 goes down there.
Oh,
Or if you want to do it your way, you were going the right direction, but you'd have one extra step then. So you divided both sides by 4, but then remember that what you found is 1 over h. So just take the reciprocal of your answer. Once you get the answer, just do 1 over that. Okay?
okay.
So h would simply be 4 over sine 25. Just flip both sides. That's your answer. Okay? Be very careful with this, okay?
All
There's
right.
only one step you can do wrong, and that's this. In this whole question, that this is the only thing that can go wrong. Algebraic manipulation. So, okay, so what is it now? What is h?
9.46.
9.46, exactly. And similarly, you can find the adjacent. Can you try to find the adjacent from scratch and tell me how you did it? Try to be as
Okay.
quick as possible.
8.56.
8.56. And how did you do it?
4 divided by 10 25.
No, the initial equation, what did you write?
Oh, oh. Um, 10 25 is equal to 4 over A.
Exactly. And now what is A? 4 over tan 25, right?
Yeah.
Okay, good. And you get 4 divided by tangent of 25, which gives me 8.58. Good. So this is how you can use these identities to find sides. Okay. Now, what if, remember how in the beginning I told you that you can use these identities to find any missing thing if I give you any two things,
Mm-hmm.
right? So if now here I gave you one angle and one side, so two things in total, right? However, what if I gave you just two sides? What if I didn't give you an angle at all, right? That's another situation. So the next idea is finding angles using SOHCAHTOA basically, right angle
Mm-hmm.
um, equations, I guess you can call them. Okay, so
Mm-hmm.
these two examples we just did, they were about finding the missing sides. Okay, so if I give you the angle, you know the angle, and you just want to find sides. So finding sides, because you see the angle was known, sine of 25, tangent of 25. But what if you have a new situation, and this time I don't tell you the angle, I call it theta, for example. Do you know theta?
Mm-hmm. Yeah.
The Greek alphabet, theta. It looks
Yeah.
like if you zoom in a lot, it looks like this. Okay, it looks like a Q, but kind of, a bit more fashionable. So now imagine that I give you this side and I give you, I don't know, like this side, for instance. And I ask you, find this missing angle. The first question is, which ratio equation should I use? So think about labeling these sides. What is this side called?
Opposite.
Huh?
Opposite.
Opposite, exactly. And what about this one?
Hypotenuse.
Exactly. Okay. So now which equation should I use?
Same.
Exactly. Sine of my missing angle equals what?
4 over 10.
Exactly. Now, the thing is, I want you to always remember, never ever put a side here. This thing always has to be an angle, okay? Do
Mm-hmm.
not, I've seen people put sine of 4 over 10 for some reason, I sometimes, which is not allowed, okay? Now, how do you solve this equation? Now, I need you to remember something very important that's going to happen here. Observation. Theta is the thing we're finding, is our unknown. And our unknown is stuck inside the sine. See? It's stuck inside the sine. Okay?
Mm-hmm.
That's a problem, isn't it? Now, that's basically the main observation. And whenever you notice that the thing you're looking for is in the sine, remember that you have to use the sine inverse. Okay, which is called the sine inverse basically. Now, why are we using this? So, why are we using this? It's simple. Let me show you an easier example of why we need to use sine inverse, which is a new thing, by the way. See, when you have x, like 2x equals 4, to remove this 2 from here, you need to do the opposite of multiplication by 2, right? Which is division by 2, right?
Mm-hmm.
So the thing that cancels out a multiplication by 2 is a division by 2. So that's why we did division by 2 on both sides. Okay, good. For example, if you have x square and you want to remove the square, what would you do? You wouldn't divide by 2, right? You can't cancel out a square with a 2, can you? You need something different now. Because now the 2 is a power. It's not a multiplication by 2 anymore. So we use the opposite of a square, which is the square root, right? Because the square root cancels out the square, not the division by 2. You see what I mean? Everything has
Yeah.
his own inverse, basically. Everything has its own inverse that cancels them out. Similarly, sine, cosine, and tangent have their own inverses which cancel them out. Sine inverse, cosine inverse, and tangent inverse. Written down like this. Sine inverse with a little minus on top. Sine with a minus on top, basically. So let's go back to our equation at hand. Sine of theta equals 4 over 10. How do we remove this sine from here? We remove it by doing the opposite of a sine, which is sine inverse. Just like we square root a square or divide by 2 to cancel out a multiplication by 2, to remove this sine from here so that it frees the theta, I have to take the sine inverse, of course, on both sides. Okay?
Mm-hmm.
So this is why I took the sine inverse. Whenever your variable is stuck inside a sine, always take the sine inverse. Same for cosine, same for tangent. The sine inverse cancels out the sine and leaves you with theta. And on the right side, I have sine inverse of 4 over 10. This will give me the angle answer. So can you plug this into your calculator and tell me what you get?
Uh, 23.58.
Okay, 23.58 degrees. Exactly. That is basically it. Okay. So remember, these are the only two scenarios you can ever have. Finding missing sides, so where you will know an angle and one side, and you're going to want to find the other missing side, or finding angles when you don't know the angle but you know two sides. Okay,
Okay.
nice. Now, let's look at some mixed kind of problems about this topic so that we can look at, what kind of more difficult kind of questions we can show up in the exam. Okay, because obviously
Uh,
everything we've done so far has been just basic, how to find a basic missing side, etc., etc. So for instance, let's look at this. So if you look at this question and you're supposed to obviously find theta, the missing angle at the top. So we call these like mixed questions because now we're not just directly giving you one triangle. We want you to use multiple rules all together and try to find the missing thing. So you see two right angle triangles here, one and two, and you want to find this missing angle, right? Now, the thing is, which triangle is this angle a part of? You see that it is a part of this triangle, isn't it?
yeah.
So now study this triangle for a second and you will realize very quickly that you only know one thing about this triangle. You don't know anything else, right?
Mm-hmm.
So you can't find anything about this triangle because you don't know enough. You need at least no, not at least. You need exactly two things or more to find any missing stuff. So in this triangle, we are hopeless. We don't know any two things. We just know one thing. So now we have to come back to this guy and maybe ask this guy to give us something about the other triangle so we can use that to find theta. So you need this kind of tunnel vision for these questions. You need to think about, think 2, 3 steps ahead. So do you see what I mean?
Yeah.
Okay. So now how would you solve this? What's the first step going to be?
So I would find the the bottom triangle.
Okay.
Yeah. Um, I'll find adjacent. Um, yeah, that thing,
Okay.
which is wait,
How would you find it? What's the formula going to be?
cos.
Cosine.
Um,
Exactly, because you have adjacent
wait,
and
wait, yeah.
hypotenuse. Cosine of 26 equals, what is it?
A over 17
Good. So then A is,
equal to cos 26 times 17.
yeah, I like to put the 17 first because otherwise it can accidentally look like I'm multiplying 26 by 17, which is
Oh
impossible
yeah,
because, yeah.
I just put
So,
the bracket. That's it.
yeah, that also works, but this looks cleaner to me. So, also it's written this way in research papers and stuff. So, I mean, obviously you don't need to worry about that yet, but we put the number
Okay.
first. Anyways, so now a word of advice at this point, a lot of students will find the decimal answer to this and kind of move ahead with that. But I suggest that you leave it like this because this calculation is just one calculator tap away, right? So just leave it. Don't calculate it because when you calculate it, you're gonna inevitably approximate it to like one decimal place, maybe two, right? And that can reduce the accuracy points in the end, right? Because you have to do multiple calculations with this. So leave it like this and calculate it when you need to calculate it. Okay?
Oh,
You see what I
oh,
mean? Like
okay.
just leave it
Yeah.
in this form because you know what it is, right? You know how to calculate this. So don't calculate it yet because it's not the final answer. So now you know this guy. Now what?
So now we can
Mhm.
find the angle,
Yeah. Which rule?
but huh?
Which rule would you use?
Tan.
Tan. Exactly. No, no, no. Sorry, you can't use
No,
tan.
wait, no, wait, no,
So this
wait.
is what?
That's opposite.
Opposite. And what is this?
Okay. So you need to use sine, sin,
Sine.
sine.
Exactly. So now here's another interesting thing I've seen a lot of people do. They're like, oh, I've already labeled this side as the adjacent, which means that this must be the adjacent. I should use cosine again. But this is the adjacent for this triangle because you see it's adjacent to the angle here. But for this triangle, this side is the opposite side. It's very easy to see once you see it, but if you accidentally are going too fast in the exam, you can miss this. Again, this is the opposite, this is the hypotenuse for the triangle we are talking about now. All right, so we use sine of the missing angle equals what?
17 cos 26.
Exactly. Divided by
25.
25. Good. So now can you calculate what this is? So first, you can actually do this whole calculation in your calculator by doing this. How will you find theta, by the way? Imagine that, just call this one thing. How would you find theta?
Um, Sine -1 equal
No,
to,
say sine inverse.
oh, sine
Yeah.
inverse.
Mm-hmm.
Yeah, yeah.
So
Over
25.
25.
So now you can just basically put that all in the calculator, but be very careful with the brackets, okay? Because if you write 17 times cosine 26 divided by 25, your calculator is going to think you're saying this, basically. So make sure you put brackets here, okay?
Okay.
Very, very careful.
Are you waiting for the answer?
Sorry?
Are you waiting for the answer?
Yes.
Oh, this is so stupid. 37.67.
Exactly. 37.67 degrees. So there you go. That's how you
Sorry.
solve this problem. All right. That's basically it, you know. I mean,
Yeah.
this is the kind of problem that shows up often in the exam. Maybe we can take a look at a bit of a more confusing looking one. And one sec, let me look for a good one. There. So we can take a look at this guy. Even though in an exam you don't need to expect something like this, because they don't they're not very graphical, at least in the GCSEs anymore. But it could come up something like this. Regardless, so angle of elevation and angle of depression, basically, what is this? Imagine that you're standing right there and you're on a cliff, okay? Or let's say
Oh,
you're on the edge of a cliff. Don't jump. Um,
okay.
Now imagine that this is like the sea, for example, and there's a boat here. Okay. Wow, my drawing is amazing. And so the angle of depression to look at the boat would basically be what angle would I need to look down at to look directly at the boat? So from my horizon view, how much do I need to look down? What angle do I need to like bend my neck basically downwards to look at the boat? This is called the angle of depression because I'm depressing my sight. And similarly, if there was a person on the boat itself, that's not what I wanted to do. There. So imagine that there was a person on the boat and they wanted to look at me. Okay. So someone right there, and they're looking up at me. So how far up, what angle upwards would they need to look at to look directly at where I am? So this is called the angle of elevation. I think it's pretty intuitive, right?
Yeah.
And this is called depression. I mean, in math at least. And I think the real world depression means something much darker. So, um, so here it says that the helicopter is hovering at a fixed position 150 meters above the ground. The angle of depression from the helicopter to house A, it says, but it never said that this is house A, is 32 degrees, which means right there. This is 32 degrees. Angle of elevation from house B to the helicopter is 22 degrees. So you see, if you were at the house, you would have to look this far up to look at the helicopter. Find the distance between the two houses. That's the question. Now, what do you think? So in a question like this, your first instinct should be, wow, I need to look for right angle triangles here because that's all you know about right now, right?
Mm-hmm.
Do you see any right angle triangles? Let's call this,
Yeah.
oh God, let's call this H as the helicopter, and let's call this point D as the helicopter. So, for example, which right angle triangle do you want to look at first?
Um, how to explain?
I mean, use the points, use the
H
vertices.
HDB.
HTB, so basically this guy, right? See,
Yeah.
HDB. Good. And do you know two things about this right angle triangle? If you do, you're in luck.
Yes.
Which two things do you know?
You know, an angle on the side.
Good. Now let's name what side we know, and let's find out what we need to find. So, what side is this going to be like? What is this classified as?
Opposite.
Opposite. What is this guy classified? No. What is this guy classified as?
Adjacent.
Yeah, kind of gave it away, but we were supposed to realize that we need to find this guy. Because if we're trying to find the whole distance, I mean, at least knowing just this part would be pretty cool, right? So,
Mm-hmm.
which rule do I use?
Tan.
Tangent, exactly. Tangent of 22 degrees equals,
150 over A.
exactly. We can call it dB because we better, because we're going to use A again here, and also A is already a thing, so, got to be a bit careful. Might confuse yourself. So, what is dB going to be then?
150
Uh-huh.
divided by tan 22.
22, exactly. And that's your answer for this part of the distance. Very tempting, by the way, to say that just double it and get the rest of the answer. But it's not really correct, right? Because they never said that this is equal. It just looks equal, which is actually pretty evil of them. So now we need to find AD, the other side of the distance, right?
Mm-hmm.
So for that, which triangle are you going to use?
ADH.
ADH. So, how many things do you know about this triangle?
1.
Exactly. But we can't really work with that, can we? We need two things at least. So how do we find the other thing?
Can you assume, you know, when the helicopters, can you assume that's 90 or
We have to. It actually makes complete sense that it's 90 degrees because look, this is a vertical height and this isn't like a flat line because that's where we calculate the depression angle from. So if this is completely horizontal and this is completely vertical, then logically this has to be 90, shouldn't it?
Mm-hmm.
Right? Again, this is height, this is horizontal, so 90 degrees between them. If this is 90 and we know a part of it, we can find the rest of it, can't we?
Yeah.
So what is this angle going to be?
58.
58 degrees. Good. Now we know two things. So which things do we know though? And what are we trying to find?
Trying to find opposite
And we know?
adjacent
Good. So again, what do we use?
tan
Tangent of 58 equals, what's it gonna be?
O over 150
O over 150. So O is,
tan 58 times 1 or 150 times tan 58.
nice. 150 times tangent of 58. And that is your answer for the rest of the distance. Of course, we found this guy and we found this guy separately. So we got to add these two together to get the final answer. Can you just check what you get as the final answer then?
611.31.
Exactly. 611.3 meters. And that's it. Okay. So that's basically all. Now I'm gonna put some homework on the board for you. I'm gonna end the recording now.